We're back. We're going to talk about relative extrema again. We have an interesting example here, x cubed y minus x cubed minus y. These nonlinear systems that we get when we take two partials are of interest. And first of all, we're going to find fx, which is 3x squared y minus 3x squared, set it equal to 0. And we're going to find f sub y, which in this case is x cubed minus 1, set it equal to 0. Now, you can factor 3x squared out, and you get that. And here we get x equals 1. There's one real 0. There's actually two imaginary zeros, but we're not concerned about that. This says basically x must equal 1. Now 3x squared times y minus 1 equals 0. This solution, 3x squared equals 0, says x equals 0 or y equals 1. But guess what? We can exclude x equals 0 because we know x has to equal 1. For this to work, both have to be 0. We need a ordered pair that satisfies this and satisfies this. And the fact that I use the word and, that has to be true. So you can get rid of that. So sometimes the logic's a little bit tricky. And we have one critical point, 1, 1, x equals 1, y equals 1. And if you plug 1 in, you get 1, 1, 1 minus 1 minus 1. I'll actually write it. Now the question is, what is it? Let me clear a little space over here. D is equal to second x partial. Need to take a partial of this. And we get 6xy minus 6x times the second y partial is 0 minus the mixed partial. You could do an x partial of this or a y partial of that. I'll do an x partial of that, a little easier. 3x squared squared. And so in any event, d simplifies to negative 9x to the 4th. Okay, now the question is, what happens if we plug this in? D of 1, 1. Is negative 9 times 1 to the 4th, which is negative 9, which is less than 0, okay? And we are right here. This is a saddle point. My guess is this is a pretty weird surface. You can find, Google 3D function grapher, and you can probably get a picture of that pretty easily. It's easy technology to find, but in any event, there's one saddle point. Might look pretty weird besides that. So, okay, that's all for this video. We'll be back with one more video shortly.